And let's put any devices away, okay? Distractions. Put them away. You don't need it. Ay, ay, ay. Your brains can't handle it. Okay. Probability of drawing a black card. Sure, you can do this, but really it's 1/2, right? So that's 0.5, that's 50%. Diamond, there are 13 out of 52, that's a whole suit. That'd be 1/4, right? You don't have to. Just 13 out of 52, you're good. You're doing good. But it's a quarter, so it's 0.25. That's 25%. Face card, there's 12 out of 52 faces. And that would be, let's just go here, 0.2308, which is 23.08%. What I want you to get used to it is that it's really probability of this, right? Probability of that. Normally textbooks or, right, if you ever pursue math further, that's how you do it officially, right? 6 of spades, there's only 1, right? Because spades, you're just dealing with that one suit, and 1 out of 52 would be spade, right? So that's 0.0192, which is 1.92% chance of getting 1. 8, 9, or 10. I don't know if you caught that, but you have 4, oh, sorry, hearts, right? Only hearts. So 1 plus 1 plus 1. So there's 3 out of 52. 3 out of 52 when it's like that, right? 8, 9, or 10, just add it up. So that would be 0.0577, which is 5.77%. Just a 5, there are 4 5s, right? So 4 out of 52, that would be 1 out of 13, right? 0.0769, which is 7.69%. A black 4, 5, 6, 7, or 8. There are 2 of each, right? 2 plus 2 plus 2 plus 2 plus 2, right? And so we have 10 out of 52 there. And that would be the equivalent of 0.1923, which is 19.23%, almost 20%. Spade face card, spade only, Jack, Queen, King, right? So 3 out of 52. You can borrow the answer here, right? There's no reason to redo all of that again if you've already figured it out. And then a 6, 7, 8, 9, or 10, right? There are 4 of each because they're not specifying which anything else, just in regular, right? So 1, 2, 3, 4, 5. That's 20 out of 52, which is 0.3846, which is 38.46%. Okay, if you get the decimal, the percent right, you know you did it right. Okay, red face card, half of your faces are red, right? So it's 6 over 52, which is 0.1154, which is 11.54%. Not red, not a red 5. So you take 52, subtract the 2 red 5s that you would have out of 52. So it's really 50 out of 52, right? I have to do the math. I just added this, right? Not a black king, right? So 52 minus, there are 2 of them over 52. So it's the same answer, right? It's the exact same answer. So we'll just go ahead and calculate that. You know that when you have even numbers, right, just keep cutting them in half. That's one way of simplifying fractions, right? So for example, 50 over 52, that's 25 over 26, right? You split them both in half because they're even, and then you kind of stop there. In this case, 50 divided by 52, that's 0.9615, 96.15%. Same with this one, right? Anyways, that's your deck of cards in a nutshell. I wanted you to have I think I'm going to try to get it in the booklet. Just a quick way of knowing your cards, your deck of cards, like not a full-blown deck of cards, just in a short, simplified version. I'll give that to you in a bit. That way you can have it on your study sheet. When rolling two six-sided die, it should be dice, right? What do you think the most common sum is? And I will kind of skip to it, okay? I won't fill this in. I will show you that if you fill out the sums, and some of you were asking me on Friday, do I include these, Mr. Dirksen, out here? It's like, nope. All you do is you include the outcome table, right? There are 36 in this case, right? 6 times 6, there's 36 outcomes. And this is the most common sum, 7, right? There's 6 of them, 6 out of 36 times that the 7 is rolled. And notice that if it's like a 4-sided die and a 6-sided die, this table kind of gets shortened a little bit, right? So it's still the most common, right? It's tied. I've got the 7 here, right? And I've got the 6s, and I actually have the 5s here as well. So 5, 6, and 7 would be the most common sums there. Okay, so watch out for how that is presented to you. I can't do every single scenario, right? So that's what you should have here. The most common sum would be 7 if it's two six-sided. So the probability of having a sum of 7, write this down. Probability of having a sum of 7 would be 1, 2, 3, 4, 5, 6 out of 36, right? And where did the 36 come from? You just multiply 6 times 6 and then you're good to go, okay? And then down here, what's the theoretical probability of rolling a sum of 9? So sum of 9, right? You go and find it. It's right here, okay? I'm going to highlight that. Right? Usually it's a diagonal thing. You're going to find out diagonally where your sum of 9 is. So there are 4 instances out of the 36 where that happens, right? 1 out of 9, right? If you simplify that. And the experimental part, you can try that by yourself. If you want to go home and do that, it's a good pastime, right? You're doing homework, right? Rolling dice. But it should after 60 trial be very close to 0.11, right, or 11%. Okay, so you can close this. Yep, up to the top, sure. There it is. One more time, okay. If you want to grab your study sheet, I will just give you a quick deck of cards, right? Deck of cards. If you want this, if you need it, and this is how you do it, right? So you've got your spades, your clubs, your diamonds, and your hearts, right? 26 blacks, right? 26 reds, like that. And every suit has ace, 2 to 10, like these are numbered cards. And there's jack, queen, king, right? So ace, 2 to 10, jack, queen, king, so forth. Like it's the same thing for every suit. If you're interested, you copy this. You can make a cleaner version of this later, but that way you know your deck of cards. Maybe at the very beginning here, I'll have 52, right? So 52 cards, half right? You can kind of cut it in half here. And another thing I will say is that I will just make a little bracket here. And these are face cards, right? Faces. There's 12 of them. There are 4 aces, 4 twos, 4 threes, and so forth. Do you need to tell yourself that there are 13 in each row? Maybe 13, 13, 13, and 13, right? And so that's your deck of cards compressed. That way you don't have to guess, like, is it 10 face cards, right? Think of a month or after the break, right? Think of then, don't think of now. Now you probably know it well, but here it is, okay? So that's part of being successful, is add it to your study sheet. Okay, take your notes now. And we're gonna go to page 163. And you don't want to go anywhere now. This is where you need to pay attention, because it's if you read the words odds, do not state it as a fraction. Okay? You're gonna write it like this: number compared to another number. Okay? Probability, you write it like this: I'm actually going to go total, not just any number. Okay, so I want you to make sure you understand that when you, because on the test it'll be probability odds, like I will go back and forth, and you need to make sure that you know what's happening, right? So odds, right, compares favorable and non-favorable events. Okay, doesn't have the total. Okay, if you can remember that, because I'm telling you, that's the number one complaint I always have is why do students put the total there? There shouldn't be a total when you do odds. Okay. So, example, right? The probability of it snowing tomorrow is, let's say, 2 out of 7. A, state the odds of snow. Okay, the odds of it snowing, or the odds of snow, right? And there's I'm going to use this. The first word I want you to recognize, like, okay, we're dealing with odds. The next word is of what happening, of it snowing. Okay, so odds has to be followed by either of, for, same thing, of something happening, for something happening, or you should have a word against, the odds against happening, or it not happening. So these two kind of go hand in hand for you to be able to accurately answer the question. So here's what we do. You will say this, okay, it's odds. I need to make sure it looks like this. And I'm gonna compare it snowing and it not snowing. That's how you're gonna state your answer. Probability of snowing and not snowing. So what would we put on the left based on the probability here? 2, yes. Put the 2 there. And this is my biggest complaint. Students automatically just go 2 to 7 and they leave it like that, right? It's like, I'm done, right? Mr. Dirksen, it actually looks like odds to me, right? You've got the colon there, but this is your total, right? Let's put a little arrow here at top. That's our total. Out of the total possible outcomes, that is the total. We don't want that. Let's just do mental math. What should be going here? 5, right? Out of 7, if it snows 2 times, then it would not snow 5 times. And this is how you do it mathematically. You just take whatever you wrote down here, subtract it from that total, right? So it's actually 2 to 5. This would be your odds of snowing, okay? And right next to it, we will say this, state, if you don't have room next to it, just go underneath, okay? State the odds against it snowing. And I won't add tomorrow because it's just too much work. So then you're like, okay, odds, got that part. And here it says against. Odds against. So you should still know that you're doing this. But because it says against, you almost want to pretend like you're standing here and you're going to put that event against you, like across from you. So we actually go like this, snow, right? And here is not snowing, right? We write it like this. We just flip it. That's all that you're doing. That's the only difference here. Odds against. Okay? So we're going to take this number and simply flip it like that. And you're good to go. Okay? So you got to understand the difference between of or against. Here's your formula. You ready? Some of you like formulas. So formula. If you're given probability of A happening, then it would be, right, the amount of times it happens over total. That's normally how it goes with probability. Write this down, okay? If you wanna, I branch off here. Odds for, and this branches off to odds against. Let me just go down. If it's odds for, then you would go A to total minus A. And this is how you would state it. You're done. Okay. If it's odds against, you go total minus A to A. And let's follow A, okay? A is here, then we put it there, and then it shows up again, subtracting, right, from the total. Same thing here, it shows up there, and it's always subtracting from the total. Okay, you use it once, and then you also use it to subtract from the total. So that's your formula to go from probability. Let's box this in. Remember, everything that's boxed in, add it to your study sheet. Okay? This is going from probability to odds. Make sure you understand that this formula gets you from probability to odds. That's the way it goes. What if it's the other way? Example. The odds of the Jets winning the Stanley Cup are 99 to 1001. Jets are doing pretty good right now. I don't follow it that much, but they're doing pretty good. Right? So do the Bombers. So it's a good time to be living in Winnipeg. A, here, state the probability, state the likelihood of the Jets winning the cup. You know that likelihood is the same thing as chance. It's the same thing as probability, right? That's the definition of probability. So we're going to do this. Probability of winning. The first thing you do, guys, you go like this, because you know it's a probability. It's going to be a fraction, right? You take both numbers. That's the first thing you're going to do. You're going to take both numbers and you're going to add them. You're going to get your total. Remember, the probability meets a total, so we add up our numbers. It's almost like you split them apart to get your odds, but when you come back to probability, you put them together. See? So there, that's the first step. And then you have to see which one of these two will I pick to go at the top. And the answer is, it's like, what do you want, right? The likelihood of the Jets winning. Since this mentioned the odds of this happening, right? We knew that this here represented win compared to, can I do this? Are you going to be okay if I do that? Not sure, right? But it's win and not winning, i.e. losing, right? So because you want the Jets winning, this is what you're after. You're going to grab the 99 here. And that is 99 over, what's this going to be? I actually did that on purpose, right? 1100. There we go. So let's come up with our decimal as well. 0.09 or 9%. Not likely. Okay. If it's under 50%, we would say it's not likely that you're going to win. It has to be 50 or higher. Then we would say, yeah, that's a good way to do it. So here we go. If you want to go, I want to give you a formula. So if it's A, remember it's always A to not A. Those are your odds, right? If you want to go to probability of A, you would just simply take those two, you add these two numbers up, that goes here. You're writing this down, right? And then you have to decide if it's probability of A, then you want it like this. Okay. If it said probability of not winning, which number would we pick at the top? We would pick this number, right? And put that on the top. So here's your boxed in formula. This is odds to probability. And you know what? Right now, we're going to pause right now. I'm going to give you a couple minutes to add this to your study sheet right now. Okay? So, because starting tomorrow, I'm going to. If a card is chosen randomly from a standard deck of playing cards, what are the odds, guys? I need you to understand, right? Some of you will make a mistake and say and think it's a probability because you just not because we do a lot more probability than odds. I will try to change that, but just be careful, right? Right away, you know that it's going to be like this: number, right? You want that. In favor, you want in favor. That is going to be pink for me here. That tells me a lot. In favor or of. Let's go like this: of, for. They all mean the same. In favor of that happening. The odds for something happening, right? Being a diamond. So we're be based on the wording. We're gonna go diamond, right? And on the other side, we're gonna have our cards that are not diamond. You're comparing to not diamond. So that would be basically your spades, your clubs, everything that isn't a diamond, right? So how many diamonds do we have? We have 13. And on the other side, watch what I'm going to do. I know that there are 52 cards. I'm going to subtract the 13 from it, right? And then I get 13 to 39, which is 1 to 3, right? If you reduce that. But I'm just going to keep it like that. Those are your odds of drawing a diamond. Okay. Against being a queen. How would you do that? The word against tells you that you're going to put the queen here because the word against puts the queen there. And so this means that you're going to have the non-queens on this side. Okay, I will do this. Arrow, right? Arrow tells me that the queen is going to be on that side. If it had said for a queen, then you put queen, not queen. Okay. So which number will you put down first? Which one is easier to figure out? Your queens, right? So how many queens do we have? We have 4. And on the other side, you go 52 minus 4, which is 48 to 4. This one we can simplify, right? Let's do it. I will do the simplify, okay? So basically, when you have this, you just divide both sides by the same number. I can divide both of them by 4. Okay. So 48 divided by 4 is 12. 4 divided by 4 is 1. So that'd be 12 to 1. Could I turn this into a probability? I could. Mr. Dirksen, does it matter if I use this one or if I use that one? It doesn't matter, right? If you want to use the simplified to turn that into a probability or this to turn into a probability, you get the same answer. Divide both of them by 4, yeah. Okay. Okay. I want you to read number 2. Yeah. Question number 2. Give it a try real quick, okay? Put some numbers down. Remember, we're dealing with odds every time. Put down the odds. What would the numbers be there? What are the odds in favor of a light bulb being defective? Right, so basically defective compared to not defective. Okay, that's what's happening here. Odds in favor, right? In favor, that tells you that the event first and it not happening. So we have 3 defective, and on the other side we would have 500 minus 3, right? which is 3 to 497. Not effective means the ones that work, right? The odds against a light bulb being defective. We've already done the work. The odds stay the same. I'm just going to flip it. I'm going to flip this, bring the 497 there, and the 3 goes there. Okay, that's all that happened there. And here's a word play, right? What are the odds in favor? Odds in favor of what? Working properly. Isn't that this number, right? These are working properly. So it's just trying to see, can we trick you, right? Or are you paying attention? It's the same thing, okay? Not effective, working, same thing, okay? Way to go, guys. Backside concept. This is a concept that you need to know. Three, odds. The odds in favor of what? A red marble. Drawing a red marble from a bag is 1 to 1. What does this mean about the number of marbles in the bag and their colors? It's an equal amount, right? 1 to 1. You thinking there's only 2 marbles in the bag? Because I told you add them up, that gets you your total, right? And that's a little deceiving, but this is just telling you that there's a, like, because if you take 50 marbles that are red and 50 that are not red, okay, red and not red, if you simplified this, it's still 1 to 1, right? So this is the simplified. So once you simplify, you can't really do that anymore. So it doesn't tell us the total number of marbles, comma, but it does tell us that there is an even number of red and non-red marbles. And you're like, Mr. This is too complicated. Can I do it simpler? Yes, you can say, I know that there will be the same amount of red marbles compared to any other color, but it will be the same. It could be 100 reds, 100 that are all kinds of different colors, but they're not red. Okay? So yeah, that's what that tells us. So okay, good. Okay, so now you're going to grab your workbook. I will write this down. Go to page 24 in workbook. The one with the deck of cards in front of it. And it's a bit of a scary looking page. I want you to take this. You go to 24. This is what it looks like. You're going to just ignore the top right now. Just ignore everything you see up here and jump right into question 1 here. And just work through those questions. Okay? Work through those questions. Careful, because I do mix up odds and probability. Okay? There's the probability here, and then there's odds there. Odds, right? So I do mix up probability and odds. But I want you to give this a try now. Kind of now that we know how to deal with odds and probability, can you work through it? Okay, so just do it. I will correct this tomorrow, not today. Okay, we won't have time today. I will give you the rest of the class to work on this, and then we'll convene tomorrow.